Good evening. We are back again to try our hand at more Advent of Code. Today is day 5. I went ahead and actually got my project all set up and ready to go ahead of time today, so we're just going to jump right in. And I'm hoping this is not going to be a long one because all these late nights, they're late. There's not much sleep happening. Okay, so let's go ahead and jump in here. We've got our puzzle. Day 5, it's called Print Queue. Satisfied with their search on Ceres, the squadron of scholars suggests subsequently scanning the stationary stacks of Subbasement 17. The North Pole printing department is busier than ever this close to Christmas, and while historians continue their search of this historically significant facility, is the music a little loud? Sounds a little loud to me. Historically significant facility, an elf operating a very familiar printer beckons you over. The elf must recognize you because they waste no time explaining that the new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services. Safety protocols clearly indicate that new messages for the safety manuals must be printed in a very specific order. The notation XY means that if both page number X and page number Y are to be produced as part of an update, page number 6 must be page number 6 page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update. Your puzzle input. But you can't figure out whether each update has the pages in the right order. For example, 47, 53. Okay, so these are our rules, right? Yeah, page ordering rules. So we can call these rules, I guess, and they're going to have an X and they're going to have a Y. And then these are our actual orders, or what they're calling updates, but they're just kind of like they're orders essentially. The first section specifies the page ordering rules, one per line. The first rule, 4753, means that if an update includes both page number 47 and page number 53, then page number 47 must be printed at some point before page number 53. 47 doesn't necessarily need to be immediately before 53. Other pages are allowed to be in between. So, based on that rule, like if we look at this first order, this is okay because 47 comes before 53. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update, 75, 47, 61, 53, 29, means that the update consists of page numbers 75, 47, 61, 53, and 29. To get the printer going as soon as possible, start by identifying which updates are already in the right order. Which kind of makes me think that part 2 is going to be putting updates in the correct order, maybe. In the above example, the first update is in the right order. 75 is correctly first because there are rules that put each other page after it. .47 is correctly second because 75 must be before it, and every other page must be after it, according to 4761. Okay. So the first thing that's coming to mind is we're going to need some sort of like a map, some sort of structure that basically lets us do like we're going to want something that's kind of like a dictionary where you can say, like in that first bullet, you're going to have like your key is going to be the page, and it's 75, and then you're going to have a list of pages that come after it. Right, so this would be 47, 61, 53, 29, and you can essentially build this up. You can build this structure up by parsing these. Right? So you get this number, this is your X, that becomes a key. And then anytime you see 47 again, you just add more numbers to that list. And then you can use that. I think that would be an easy way to look up and see, okay, it basically be an easy way to look up and see what depends on what, right? Almost like a graph. It's kind of like a graph, but I'm imagining it's just a single level. But I guess it kind of is a graph, right? Because if another number references 75, I can just pick 75 and then get that 75 and find out what it depends on, or what depends on it. So yeah, it's like a graph. It'll be a dictionary. I think it'll be a dictionary in terms of the implementation, but it'll essentially be a graph sort of structure. So that's the first thing that's coming to mind. Okay, so hold on. Let's go back to this. 47 is correctly second because 75, okay, I already talked about that. So it's basically just enumerating why these are correct. Okay. Because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. So I guess that's just basically saying we only have to look at order or rules that reference the numbers that are in our actual order. The second and third updates are also in the correct order according to the rules. Like the first update, they also do not include every page number, and so only some of the ordering rules apply within each update. The ordering rules that involve missing page numbers are not used. The fourth update, 75, 97, 47, 61, 53, is not in the correct order. It would print 75 before 97, which violates the rule. So that's where having this is going to come in handy, right? Because as I'm going through this list of numbers, I can basically keep track of what I've seen, right? So I can loop over this and say, okay, I've seen 75. And so then on this loop, I can check and see, okay, what numbers have I, I can check and see, okay, for each number I've seen, so like 75, does 75, does this map, right? So if I look up, okay, this is the number I've seen, let's look that up here. Does that have a dependent, which is 97? And if it does, then it's violated it, right? Because 97 has to come before 75. So we're gonna have a loop with, and then another loop within it. And the outer loop is going to create the inner loop, essentially. The fifth update is also not in the correct order since it breaks the rule 29. Okay. The last update is not in the correct order due to breaking several rules. For some reason, the elves also need to know the middle page number of each. That's random. The middle page number of each update being printed. Because you are currently only printing the correctly ordered updates. You only need to find the middle page number of each correctly ordered update. Okay. So basically, we're going to use these rules to figure out which orders are valid. And I'm assuming, I guess, every one of these is going to be odd. So that way there's a middle number. And then whichever orders are, in fact, valid, we'll get the middle number. And then what does it want us to do? It wants us to add them up. Adding these page numbers together gives 143. Of course, you'll need to be careful. The actual list of page ordering rules is bigger and more complicated than the above example. Determine which updates are already in the correct order. What do you get if you add up? Yeah, what do you get if you add up the middle page number from those correctly ordered updates? Okay. All right. So I'm going to take the same approach that I've taken before, which is basically the first thing I need to do is I need to parse the input. And I'm going to parse the input into two sets of lists. No, this is going to be parsed into the dictionary that I talked about. And then this is going to be parsed into lists of numbers, basically. So it's going to have I'm going to have a list of lists, my orders. I'm going to have a list of orders, and then I'm going to have some sort of dictionary, and I think I'm going to separate this up into like a couple of classes. So we'll have the puzzle parser, then we'll have some sort of like validator class that holds this dictionary and can accept an order and then validate it. And then this, how do I want to do that? I guess that can just be in program. That can just be in the main method, and I can just say, I can just say orders.select, and then, or no, orders.where, and then order.validate. So I'll have something like, I'm going to have multiple. Trying to think of how I want to read this in. I think I want to read in all the lines. Then I'll have an empty one. Split list on empty value, on empty element. That's something you can do. Or maybe I want to read all this in. Yeah, let's do read all text. And then we'll say bar input parts equals input dot split on string dot or environment dot new line. Isn't there like a string trim? What is it? C# split string on empty new line. Oh, so it's just new lines back to back. Okay. Yeah, I think that's okay. Split on new line. So then that's going to give me, I mean, should that be in the parser? I don't know. Yeah, we can test it then, right? I mean, what are we going to call it though? Let's call this output instruction. Down here. And so what this will do is we'll have a parser, or parser equals new parser. This guy will have a something called parser dot read instructions. Actually, there's probably nothing wrong with just having a tuple, right? So it's a puzzle parse, and then this is going to return, the first thing is going to be order validator. And then the second thing, no, let's call this, let's actually do, this should just spit me back a diction. Oh. I'm trying to think of where the logic should live. So this is going to be a list of order rules. And this is going to be a list of orders. Or should we, what do they call them updates. Maybe I should call it update. List of updates. Let's go ahead and we'll make some classes here. So we're just going to have record types, order, rules, and they're just calling it int x. then int y. And then record update. And that just has a list of ints, which are the pages. Oh, and then we need a puzzle parser class. Class puzzle parser. And that's going to have a parse method public. Public this, right? I'm actually going to make another record that's just parse result. That is these things. Purely just to keep this way I can say result or parse result. I know I'm very good at naming things. Excellent namer. Public parse result parse, and that will take a string. And that's the input. And right now we're just going to throw new not implemented exception. And then I'm just going to basically work on one thing first. So I'll do that. Go ahead and add a test class here. I might be one of the slower programmers the world has ever seen. Puzzle parser tests, yes. Read only puzzle parser. And then we'll have a test. The easy task parse. And given sample input, it should return expected rules. Expected rules. We'll focus on that first. So I'm still breaking the problem down to small chunks. The parser is only going to expose this parse method, but within this class, I'm going to have some private methods that actually do the logic for each thing. So, so the very first thing I'm going to do here is, let's finish writing this test. So we'll say var result equals underscore dot parse, and then we're going to have our sample input. This is a pretty big example right here. Did the music just get louder? God, it sounds louder to me. Maybe it's just the song. There you go. That's better. So we'll call this our sample input. Read only string sample input. What sample input? Well, actually, this can be private const, private read only const string. I don't need this. This is going to be, I need to pass our input here. Okay, that'll stop yelling at me now. And then I'm going to take this guy, copy, paste. What the heck was that? Yeah, so we basically just want to split this. It's 2 new lines. Okay. In any case, the thing I want to assert is that I want to await assert that result dot await assert dot that. Oh, and I know I've said this in a lot of other videos, but I'm using this new test framework called TUnit, which is why the assertions are kind of funny. They're all asynchronous, so you have to await them. So all your test methods become asynchronous as well. Kind of interesting. You don't have to use TUnit's assertion library. You can use, if you're used to using Fluent assertion, you can use Fluent assertion, but they provide an assertion library out of the box. Dot that. Oh, dot orders. Dot rules. No, dot updates. Yeah, rules. Dot is equivalent to. Then I'm going to have a new list of. No, new list of. Did I really call that order rules? Yeah, this should just be order rule. Oh, and these should all be capital rules. Updates. So these are essentially public. By declaring these in the primary constructor of a record, these become public properties. So rules, but they're immutable, so they just have an initializer. You can't set to them. But you can't do like result dot rules equals. You can't do that because this is init only. Just kind of nice. It's a real the record features a really nice addition. So what am I expecting here? An X and a Y that basically just lines up with all these. So I wonder, can I do this? I'm gonna try to do this in one go. Here we go. Let's see, cursor. We're gonna say new, and then boom, boom, boom. Yeah, look at that, dude. Multi-cursor support is the shit. I'm 30 minutes in. Somebody's already solved this in 30 minutes. I'm just so slow. Okay, so this should build. This should build now. And that should bring up my tests, hopefully. Need to refresh my tests. Then just switch over to my Oh, I always do this. Close the tab. There we go. This should fail because we have not implemented anything yet. Okay, so let's get our orders parsed. So the first thing we're going to do is up in the top, in this top line method, we are going to say input parts is equal to string, is equal to input dot split, and we are splitting on this. All right. And then for now, I'm just going to say return new parse result. And it's going to be empty, empty collections. Like, isn't that like that modern C# syntax, right? Like, just like nice. It looks, I mean, it's like it's as flexible and as convenient, as ergonomic, right, as writing something like JavaScript, but with all the performance and features and benefits of a compiled, statically typed language. Yeah, I just love that. I love this feature, this collection expression initializer. I don't know what the right term is for it, but I love it. Okay, so we're gonna have a method here that's we're gonna say this is gonna be var rules, and we're gonna call it parse rules, and that should take input parts 0, and we're gonna have a private to return a list of rules, list of order rules. Input is still a string, and now we're going to actually do this. So I think we can almost do this all in one go. So let's say return input dot split on new line, and then on new line, and then we're going to select that string. So now we're just looking at one of these strings, and we're going to say s dot split on the pipe character. Let's actually make this a body. Split, select, and then dot to list. So this is going to be var what I want to say, var parts equals s dot split there, and then we'll return new order rule, and this will be int this will be int dot parse parts 0 int dot parse parts. Nice. I guess I could have turned it. I can turn this into a link expression, can't I? Like nested in here. Let's say dot select is going to be new order rule why doesn't that work? I'm doing something wrong there, but I'm not gonna waste more time on it. Okay, and then here we should return our rules. And my hope is that this should pass now. Fantastic. Okay, now we're going to get our updates. Parse updates. Input parts 1. And then we'll just have another private list of updates. Updates string input. And again, it's pretty much the same thing where we're going to be return input.split. And then we're going to select and we're going to say s.split again. But this time we're going to split on a comma. Then we're going to say select, and we're going to say int parse dot to list. New update. Yeah, there we go. Ooh, that's a little messy. And then this is going to be updates. And I'm going to make these static because they're private. And they do not deal with instance data. So it's not a big deal for them to be static. I don't care for public methods to be static. But private ones, to me, are okay because they're not going to really impact your ability to test, because since they're private methods anyways, you're not going to test them directly. You're going to test them through the whatever public methods call them. So I'm okay with those being static. Puzzle parser. Okay, now we need to basically recreate this test, but now we're going to check to make sure it gives us the right updates. Should return, hold on. Should return expected updates. This now should be an update. This should be updates. And then I just need to kind of do my fancy trick again here. Control Alt, Control Alt. So we will say new And then we can have a collection expression. That, oh, that, oh, what happened? Somehow I got my cursor off there. Oh, gosh dang it. There we go. And let's build. Refresh the tests. Nice. So I think everything's passing now. Why am I? Okay, so my parser is working. The next thing I want to do is I want to implement my validator class. So my validator class is going to take in my validator class is going to take in this. I mean, it could be the validator could take in the whole result, honestly. And but what I kind of want is I kind of want something like var validator equals new new update validator, and that takes in the parse result dot rules. And then I kind of want to be able then to say something like var result equals parse result dot updates dot where validator dot validate update, and then I think for right now just be like toList, which is going to be a list of lists, or no, list of updates. Yeah, and then like an update has its numbers, so then I can. Yeah, I think I'm going to do this. So then let's make a new class. Update validator. And it's going to have, oh, it needs a list of rules. List of order rules. And then it's going to have a public method that returns a bool that's called validate. And it takes in a update. And then it just returns whether it's valid or not based on these rules. But what I really want in the validator is not really the rules. What I really want in the validator is this structure, right? So what I really want is I want a private read-only dictionary, and that dictionary is going to have keys that are int, and then it's going to have a hash set, because these are pages. So the pages, so it should be unique, right? All the numbers underneath, all the numbers that follow a particular number should be unique, right? We can't have 75 and then 47, 47, 61. So there should be a hash set of ints, and then we're gonna call this. What are we gonna call this? I mean, it's a graph, right? I mean, that's what this is. So, and then I'm gonna actually, I might be able to use a primary constructor, but I'm gonna start with just a good old list of rules. And then what I need to do is I need to iterate over rules, rule, and then I want to build up the dictionary. So I want to say if graph dot contains key rule dot x. What? Oh, I'm using the wrong type. I keep wanting to call it rule, but I called it an order. So rule dot x. Then let's say if this is false, then we are going to say graph dot add rule dot x. And is this a new? And then because we can do this up. Just do this up. So then we'll have that. If, and then if graph dot contains So I'm trying to translate this into this. So the first time, so like if I counter 4753, if the graph doesn't already contain 47, I want to add like this. I want to say and graph rule dot x dot add rule dot y. Right? So if this particular key is not already there, I'm gonna add it empty collection. I'm going to add its dependent value. If I kind of would like to be able to validate, though, that like I almost want this to be public so that I can test it. Yeah, that's what I'm gonna do. I'm gonna make this public. I'm gonna call this graph. And this may change. I might make it private again, but for now, okay, so if it already has X, we don't actually need it. Because we need to do that every time. Okay, let's make a new test class. I thought I knew what I was doing, but now I'm second guessing myself. Update validator. Oh, nope. Rename. I want to call this update validator test. Just in a private, read only update validator underscore validator equals new. No, it can be new. It goes new. And let's see, our actually, my I can't do that. I don't want to. So test, no, private, read only, list of order rule underscore example rules. For now, this is going to be an empty collection, but I'm going to go over here to my puzzle tests. And these are actually the rules from our example. Those are the rules we want from our example. That. And let me just collapse that down. And then I'm going to have a test. So public async task. Graph. When given example rules, it should build expected graph. Let's see, var install or no var validator gonna be equal to new update validator example rules, and then I want to assert that dot graph assert dot that validators graph is equivalent to new dictionary of int hash set int we'll actually need some actual values in here. So I know at least I should have 4753, right? So 47. How do you do this? I can never remember how to initialize the dictionary. So I know I should have this, and this should have 53 in it. This should have 13 in it. This should have 61 in it. This should have 29 in it. I'm gonna have to just kind of do this by hand, aren't I? Let's see. We got 97. '97 should have 13. Should have 61. It should have 47. It should have 29. 53. 75. Yeah, it's gonna take me a minute. Let's see. This should have 75. So 29. 3. 47. 61. 13. I don't know how else to go about making this any faster, but 61. As we go down this list, it should go quicker though. 61, 13, 53, 29. Yeah, 13, 53, 29. So that's it. 97. Oh, we already have 97. We already have 61. We have 47, 97, 75. We have 61 already. We have 75 already. We need 29. So you can kind of see you can almost see the graph here where, like, if you get 29, you can check and see if, like, or let's start up here, 47. So if 47 gets 53, that means 47 needs to become 53. If we get 53 or 61, let's say if we get 61, we can look up 61. 61 needs to come before these. So yeah, it's like a graph. Okay, 29 has 13, and that's it. 97, 53. Do we have 53? '53 has 29 and 13. 61, 47, 75. Yeah, I think that's all of them. 47, which we have. 97, we have. 75, we have. 61, we have. 75, we have. 29, we have. 97, we have. 53, we have. 61, we have. 97, we have. 61, we have. 47, we have. 75, 97, 37, 75, 37, 75. Yeah. Okay. So let's go ahead and test this and see if we get what we would expect. System collection generic. God, I'm slow. An hour and I still haven't finished part 1. That looks right so far. We should have 5, right? We should have 5 numbers. 47, 97, 75, 61, 29. Oh, we should have 53 too. Yep, 53. What? Why do we have 6 now? Oh no, 6 is right. Yeah, 6 is right. Yeah, that's right. Can I move this window? Oh no. Don't do that. One, two, three, four. Yeah, there should be 6 there. $53. 97, 13, 61, 47, 29, 53, 75. Okay, that's right. 5. Okay. 13, 53, 29, 13. Yeah, that should be right, right? What? So why doesn't it like this? but it is system.collections.dictionary system int 32. Why are these not equal? In my mind, these things should be equal. Is equivalent to dictionary. He didn't look like he tied a pull request to that. But what am I doing wrong here? Is equivalent to the same type. Is it just because I'm doing it on a property? Like, if I was to say var graph equals validator dot graph, this probably just has to do with me not understanding how what I'm doing wrong. The exact same type. Ugh, that's annoying. Fluent assertions be equivalent to with dictionary. Here's maybe I should do equals then. Is equal what is this? I think that's what I want, is equivalent to, but I don't know why it's failing. I'm gonna have to ask ChatGPT because I don't understand. You explain this assertion or oh, I wonder if it is the order. Yeah, I'll bet it is the order. No, that's all right. Maybe it's the order of my numbers within the values. 29, 13. This should just be 13. 13, 53, 21. That's right. Oh, here we go. So this is a count of 5, right? So 29, 53, 47, 61, 13. That's right. 97, 97, 13, 61, 47, 29, 53, 75. Cool. 53, 13, 61, 29. Okay, so it's not the order. I mean, that's... Oh man, I'm stumped why this test will not pass. It's something silly. This is going to tell me that I can use a... What if I do graph.keys and graph.keys? Does this pass? Okay, that passes. So I don't know I don't honestly know what I need to do to make the values. Yeah, okay. I'm happy with that. I know it's right, so that's okay. So, wonderful. We have our graph. Now what do we want to do? Now we need to implement this actual validate method. Okay, so the base case is going to be true. And then we're going to say for each var page in update.pages. This should be this should be capitalized. Okay, so this is where we're gonna look at the pages, and we're gonna look at the pages and check and see if it's a valid order. But the only way we know if it's valid if all the pages that preceded it are okay to precede it. So that's where we're going to need to say var pages looked at, or var previous pages equals a new list of int. And then we're going to say previous pages dot add previous to add page. And then we'll say for each var previous page in previous pages, we want to say if graph dot contains key what am I checking for? I want to see it if the previous page, yeah, so if it contains key previous page and then if graph previous page, which is the hash set dot contains page, then we need to return false. Okay. Okay. It doesn't look as clean to me, but if that's what's preferred. So what am I asking here? Okay, so if I go back to my puzzle for a second and think about this, what I'm doing is, let's say I'm down here on this order, this update. I'm going to loop over each page. So let's say I'm on 75. We're going to say 75. We're going to add that page. 75 doesn't have it. There's no previous pages yet, right? So we'll just pop over. Now previous pages contains 75. And this page is now 47. And so we'll add 47 to previous pages. And then we'll do our check to say, hey, let's go over all the previous pages, which now has 2 in it. Oh, this probably should actually go. That doesn't make sense to. This should go down. Oh, what am I doing? This should be previous. Stop add page. Okay, so then let's back to where we were. So we have 75 in the previous pages. Current page is 47. So now we're going to check 75. And we're basically going to look in our dictionary here. Right? And we're going to say try get value previous page. That's going to return us this hash set. And we're going to say value contains this page. So if 75 contains 47, we're going to return false. Which is not. So that's wrong, right? So we're going to say value contains page. Yeah, so if previous page contains this number, it's okay, because 75 should have come before 47. So what we're really looking for is contains page is false. Am I doing that right? I think so. I think I'm doing that right. So let's give it an order and let's try to test this real quick. So test public async ask validate when given valid update, it should return true. So var update is going to look like this guy. We'll say new list of int. Oh, actually, no. This is going to be new update. And then we're going to say var result equals new update validator. That takes in our example rules. Then we try to validate the update. And then we can await search. This is going to go another 3 hours tonight, I think. Search dot that result dot is equal to true. Oh, no, actually. Okay, so I did do it right. Yeah, if value contains false. Okay, so let's try some of these other ones. Because that's technically that's our base case. So if I have messed something up in here, it's likely this could be a false positive. So let's try. Let's actually say update, update. Oh. Give another one for update. Okay. Second and third are correct. Okay, so let's do those two. Var update 3 equals new update. Okay. Now, the fourth update is not, the fifth update not, and then sixth is not. Okay, so test public async task validate when given invalid update. It should return false. Is false. God, I hope part 2 is not really difficult. Result 2 is wrong. 61, 13, and 29. Let's close that. Let's make this bigger. And let's jump into the debugger. This is the statement that really is at the heart of it, isn't it? I need to come up with a method for this. Let's see. Test D. This one's fine. This is the one that's going wrong. So step over. What's happened? I think I hit the wrong thing. Stop. This one's fine. This is the one I want. Skip over, skip over, over. Previous pages is empty. Okay. So now we have 61 and we're on 13. Okay. So previous pages is 61. 13. Does not. Yes, it does. Value does contain. So why is that not hitting? Okay, so that's found true. Okay, do I not understand? I feel like maybe I'm not understanding why it should fail. The fourth update is not in the correct order. It should print 75 before 97. Oh shit, so should I? Because I think what's happening is that I'm missing. Right, because I'm basically saying I'm basically checking to say, hey, does 75 contain 97? Do I have my logic flipped here? I feel like maybe I have my logic. I'm close. I can feel I'm close. So 47 needs to come before 13. So if previous page contains the current, then we're good. Right? I feel like I'm losing my mind. I'm losing my mind a little bit. So let's just isolate on this one, 6113, right? It's wrong because why? It's wrong because since 29 needs to become before 13. So when we get here, right? When we get here 13, or no, when we get here to 29, this is going to be 61 and 13. And this is going to say previous page 13. Oh, it's because 13 isn't in my graph. I need to say if graph dot if contains y is false, graph dot add rule dot y, and then this is going to be empty, and we're never going to add anything really here. This should just be empty. It's going to break my other test, but I think it's going to make this one pass. Yeah, that's what it was. So basically the problem was because I didn't have 29, is it? Was it in my... No, 13. All right, so when we got to 29, and I went over the previous pages, I couldn't, when I got to this line right here, and the previous page was 13, I wasn't getting a value back, but now I am getting a value back that doesn't contain this page, right? So value contains page is false, and now we hit this line. So that was my mistake. So then up here, it's actually going to look like this. It's going to look like this graph is good. So this test is broken now, though. So if I replay this test, run, this is going to break now. Yeah, which is expected. So what does that graph actually look like? That graph actually looks like let's just debug it. Debug. So it just has one extra, which is 47, 97. Yeah, it's just one. It's just this guy. Okay. So this should be 13 with a nifty hash set. Now that should pass. What? Oh, the order's wrong now. Okay. The order is wrong now. I really like this Explore view. It was really nice. I wonder, I'm guessing VS Code has something similar. There should be 47. Should now be 47. Then 53. 97. Then 13. 61. 75, 29. Give me a green check mark. Oh. Just run them all then. What is... Okay, hold on. I've got something hung up here. Done this a couple times. Whenever this happens, I just start ending all the .NET host tasks. And then let's now try again. Okay, let's shut Rider down too. Oh, we're so close. We're so close. I'll give it a second here. Ugh. It's rough. There we go. Okay, everything succeeded. Okay. So let's go back to our program.cs. And we really just have one final step here, which is we get the validator. And then we need the middle number from the valid orders. So we know we have the valid orders now because our validate function works. And then I'm or not order, the middle number from our updates. So I'm just gonna add that to the update class, and I'm gonna say this is a public, turns an int, and I'm gonna say get middle page, which means all we're gonna do is we're gonna do pages pages dot count or length. We do count, divide by 2. That should give us middle page. And let's add a class for that, because we should add a class. We should add a test. Just trying to practice good habits, you know. Test method, public, async task. Get middle page. When called, it should return expected. So we'll say bar result equals new update. We're going to pass in a list. Get middle page. Await. Assert. Dot that. Result is equal to something. But excuse me. Well, what's the index? I don't probably need to account for an empty collection, but now I'm hung up on it. Index is 0. If pages dot count is 0, throw new application exception. Actually, let's make this nullable. No, I don't want to do that. Pages is an empty pages. Middle page. We just return 0. That's fine. Okay. There we go. Okay, let's go to okay, so middle number should be 61. Awesome. So now what we can do is in our program, we can say select update u.get middle page number dot sum. That. Test public async task get middle page and called should. Oh, actually, let's just do that up here. So we have all these, and we know the first 3 are the valid ones. So page equals the plus update in comma semicolon and then we will do updates dot select u goes to u dot get middle page dot sum that up, and that should give 143. Let's run that. Nice. Okay, I think we're ready. Let's sum of the page numbers is wonderful. So let's go ahead and run this with our input. Q, and then we're going to say 05. Uh-oh. We crashed. Looks like we crashed when we were parsing. The input string let's program split. Okay, let's debug this. Puzzle parser. Test. Public async task parse. When given puzzle input, it should return expected results. And then we're just going to have a private method that we've had, private async, return a task of string, get puzzle input, and all we're going to do is we're going to say return await file.readAll text app.combine app context.base directory and the name of our file. So bar input equals await puzzle input, and then we will say bar result equals puzzle parser dot parse input await expect await assert that result that result is not null. That's purely just so I can step through this. So let's get to here. Build this test. Oh, so I probably do need to split on. Oh, this isn't JavaScript, Steven. There we go. And this should be environment inline. Okay, now let's go back to our terminal. Now let's try to run it again. 6260. Come on, Steven. Yay! Looky there. Yeah, I'm proud of that one. The part I'm proud about is this part. This little thing here. The validator. This graph, that's the part I think that's the clever bits. Maybe there's a better way to do it, but I think that's clever. And I like this. This is nice, fluid. Yeah, I like that. I mean, you could probably have you could probably build the graph and then pass the graph into like a validate function on the update, but yeah, I don't know. I'm okay with this. So let's where should I add this? I want to add a test for the actual puzzle. So not update tests, should we? Yeah, let's do it here. Let's just do it here. Since we already have the result, so all we need is this. I probably should create a separate, like a whole separate class, but I don't want to do that. This is good enough for admin of code. Ah, that took me more than 2 hours. I am the slowest solver of these things in the entire world, I guess. I don't know how to be faster. It takes me that long to think through the problem. Huh? Oh. Yeah. Find and replace with this. What did I do? Did I do the wrong? Carriage return new lines with that. There we go. Oh. Private, read only, string. Okay, and now I want to let's pull these out into separate classes. I always hate putting records in a file all by themselves. It looks kind of dumb, but whatever. I was really hoping to be done with this by now. I just see people do this in like 20 minutes, and I might be working too hard at doing it with all the, test-driven development, and that may be what's adding to the overhead of my time. Okay, get add, get commit in feature solve day 5 part 1. Wonderful. Okay, now we get to go to part 2. Okay, part 2. Actually, inspect. HTML to Markdown. Excuse me. Yep, it's what I thought we were gonna have to do. We have to order the we have to order them now. Which I think the graph is gonna help with. So while the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. After taking only Okay, so we're going to take the incorrect ones, we're going to correct them, and then we're going to get the sum. So this is okay. So if it is part 2, so I'm just going to say validator.validate is false. And then we're going to say select u validator dot sort. Yeah, I think it has to live in the validator because that's where the graph is. At least for the moment. No, not order. Update. Sort. Um. So how do I order them? Just swap their positions. Basically, this when we get to this point, we basically I think what we do is we say, okay, you're not in the right order. So then we say, we're gonna sort you. So we say var sorted var pages equals update dot pages dot to list. Then we say for each page in pages, I think we want a for loop. Var page equals pages I, our next page equals pages I plus 1. So basically the question I'm asking is the next page a dependent of the previous page? Great. So is 60 or no, is 13 dependent on 61? No. Is 29 dependent on 13? Does 29 contain 13? Then we need to switch them. Or no, is yeah, I think that's the question. Is current a dependent of next? Then we need to switch them. So if current it's basically this, it's basically very similar to this. maybe I can declare a private function and say private bool is out of order. Then I can say is the current page a dependent of the next page? So we'll say current if so bar dependent equals graph dot try get value if graph dot try get value, which is going to be next page, out bar dependent, and then I'm going to say return true, otherwise return false. So if I don't know if this I don't know if I'm on to it. Yeah, okay, let's say test public recent past sort when given invalid update, it should return sorted. To return new update sorted. These are all bad. So this should be sort now. And these should be is equivalent to update so this should become that. Should become that. And this should become that. Let's build it. I doubt I'm going to get this right. So were all of them right except so this was correct, result 1. And this one was correct. But result 3. Result 3 is 97. 29, 40, 13. So why didn't these flip? I think it's because I have to do the same walk. I basically need to do the same thing. Okay, so let's think about that. Can I reuse this logic? Let's make sure I understand the problem. Validator tests. Update validator sort. Sometimes I just pause because I get stuck in my head thinking about the. So. That one works. It's this one. So we're going to step over. Step over. 9713. Okay. So my idea is okay. So let's see. My idea is. I don't know if this is a good idea. Uh, Yeah. Which I think this is like a I think this is like a bubble sort. And I'm just going over it again and again. And okay, let's try. I'm basically going do you know do switch do switch do switch. Okay, so I feel like this logic is though redundant. Like if I flip these, oh, whoops. I guess this could be like previous page, future page. Or even it could be could change this into a do while loop or a while loop because maybe stuff we pass in here isn't uh, valid. Um, Yeah, we're going to sort it. We're not valid. We're valid when we're validate returns false. Sum them. Part 2. Oh, I probably should. Oh no, I checked all those. Those all sort correctly. Okay. So what we can do is we can do that. Part 2. Felt fast. 20 milliseconds. Yeah, I did it. Oh man, that second part kind of had me freaked out a little bit. So I'm pretty sure. Where did we put the puzzle test? We put that in the parser, didn't we? Parse when given puzzle input on part 2. Yeah, awesome. Fantastic. Although the one thing I do want to look at is the validator. Where's my validator? Yeah. This seems inefficient. Yeah, I'm not going to mess with it. It solves the problem. It seems fast. I mean, it's 21 milliseconds. I wonder if I can get that lower, but I don't like the fact that I have to, that I sort it and then I walk over it again. I know. I'm sure there's a better way to do it, but I'm happy with completing it. Let's update the README. This is gonna be that. And this is actually going to be print you. Yeah, that's right. Okay. It and git commit him feature solve date 5 part 2. Let's go. All right. That's going to do it for me. Wasn't any faster than the last one, but I mean, it is what it is. We're making progress. 5 days in, 20 to go. Goal is to make it past day 15. I'll see you in the next one.